Okay, so this is a great question because you get to fill in this whole chart, and there's all different ways around this chart. One thing you want to know is the total angle deficit is 720 for each of these shapes. And also chi equals 1, which is exactly the same as saying that the angle deficit is 720. Okay, what are the duals? Well, I know that the cube and the tetrahedron are, tetrahedron is self-dual. It's the cube and the octahedron. Those guys are duals. And the icosahedron and the dodecahedron are duals. Well, how many faces are in these various shapes? Dodeca, that's 12. Do is for 2. And deca is 10. Tetrahedron, octahedron, that should be easy. Cube, you know, has 6. And so icosahedron must be the 20. Icosa really does mean 20. Yes? Mm-hmm. Cube has squares on a side. Icosahedron has triangles. Tetrahedron has triangles. Octahedron has triangles. The dodecahedron has pentagons. There we go. Now what? Well, we can find out the deficit per vertex if we figure out what's meeting. The dodecahedron is 3 pentagons meet at a vertex. So 108 we know, or we can calculate it, is going to be 324 degrees. So the deficit at each vertex is 324. There's 360 minus 324. So we just say 360 minus 324 gives us 36 degrees. All right, tetrahedron. Tetrahedron is the smallest one, and we have 3 of these meeting, whereas icosahedron, 5 of these meet, and octahedron, 4 of these guys meet. Cube, 3 of these squares meet, but they're bigger. So we can figure this out. Tetrahedron, 3 times 60. So we have 360 minus 3 times 60. Should tell us what the deficit is for that one. 180. The next icosahedron is 360 minus 5 times 60. It'll give us a 60 degree deficit. The cube, you know it's 90 degrees. Let's pretend you didn't know though. So 360 minus, how many? 3 times 90 gives you 90. And the octahedron. So it's 360 minus 4 times 60. That's not what I said. 360 minus 4 times 60. 120. I'm going to draw you some pictures so that you can see what these vertices look like. So again, the dodecahedron, I'm going to just say, looks kind of like, let's just say 108, 108, 108, if you look down on it. Okay, the tetrahedron is going to look like 60, 60, 60, and all this stuff is missing. The icosahedron has this kind of shape to it, right? 5 of these guys are there, and then there's a 60 degree angle deficit. The cube, you can just draw it kind of like this. This is what its vertex looks like. 90 degrees is missing. And the octahedron looks like this. 120 degrees is missing. I mean, I guess this is a little inconsistent. It's very hard to draw 108 degree angles. So I'm going to make this the missing wedge, the missing 36 degrees, and then maybe go, so this is 108, 108, 108. Okay, now you have little schematics for what each of these vertices kind of look like before they're folded up. Okay, now if we have the deficit per vertex, and we have the total deficit, then we can find out how many vertices we have, right? So let's do 720 divided by 36 equals 20. And then you can go down the whole chart this way, or you can remember that we have this duality going on. The number of vertices for one shape has to match the number of faces on its dual. Tetrahedron is a self-dual. Cube and the octahedron are each other's duals. So all we have left is the edges. Great. Well, we're going to make use of the fact that chi equals 1 is vertices minus edges plus faces minus what I'm calling so scientifically blobs, which is three-dimensional volume elements. Yeah, that's not an acronym. That's just a silly word. Okay, blobs. Okay, vertices, faces, and edges. So what about the dodecahedron? Whatever we get for edges has to match the number of edges in the dual. So we get kind of a 2-for-1 sale. All right, so vertices, for example, in dodecahedron, minus edges plus faces minus blobs. Okay, so we get 2 equals 32 minus E. That's the same as saying E equals 30. All right, that's great. Let's go back and do the other one. Here, we'll do 2 more. Okay, cube, we have faces, vertices, blobs. Great. 2 equals 14 minus E. E equals 12. Great. 2-for-1 sale. Why are they 2-for-1? Because faces and vertices are both positive component, like they both count in a positive way. And so, yeah. So it doesn't matter. You can swap them and it doesn't change the formula. Okay, what about tetrahedron? Okay, vertices and faces are both 4. Blobs is 1. Okay, then you get 2 is equal to 8 minus E, which is E equals 6. Okay, and this chart is complete. And I guess that's about all I have to say about that. Oh yes, one more thing. If you don't want to use chi, there is one more way you can figure out the edges. You could say, for example, I'll just do this for one shape, dodecahedron. You have 5 sides times 12 faces equals what? 60. But then you're off by a factor of 2, because if you cut all these little pieces out of paper, you're going to put 2 of them together and the edge is going to count double, right? So that's not a big deal. You just divide this off by 2 is 30. So you could do that, and you could do that for each of these shapes, and then you wouldn't have to use chi at all, and you'd still get all the same answers. Okay, hope that was fun.